In this video, we're going to be talking about congruence in triangles. We're going to start by talking about congruent figures. Congruent figures have the same size and same shape. Corresponding sides and corresponding angles are congruent. So for example, if you have this statement, triangle ABC is congruent, and that's the symbol for congruent, is congruent to triangle PQR. Well, let's look at the order in which we actually list our vertices here. AB and PQ are in the same corresponding positions. So that means side AB is congruent to side PQ. BC and QR are in the same corresponding positions, so those segments are congruent. AC and PR are in the same corresponding positions, so those segments are congruent. So we've listed the sides here. Now the angles. Angle A and P, or the letters A and P are in the same corresponding positions. They're both first, so angle A is congruent to angle P. B and Q are each in the second position, so that means angle B is congruent to angle Q. And angle C and angle R are in the last position, so that means angle C is congruent to angle R. So if we wanted to label these two triangles, we know angle A and angle P are congruent. Angle B and angle Q are congruent. Angle C and angle R are congruent. AB and PQ are congruent. BC and QR are congruent. And AC and PR are congruent. Let's move on to the next page. Now, it says NPLM is congruent to EFGH. These are two quadrilaterals. And we want to find X and we want to find Y in these diagrams. So let's take a look. Well, angle E has the measurement 7y plus 9. Well, in our congruent statement, E corresponds to N. They're both first. So 7y plus 9 is going to have to correspond to the measure of angle N, which is right here. So that's 72 degrees. So that means that they are congruent. So we can actually write that 7y plus 9 equals 72. And that's because angle E is congruent to angle N. Now we have an equation that we can actually solve. So let's subtract 9 from each side. So we have 7y equals 63. Divide each side by 7, and y is 9. Now we also have to find x. So let's look over here. Measurement 2x minus 3 corresponds, or is the measurement, I should say, of side HG. Well, let's look at our congruence statement. I'll use a different color. HG, they hold the fourth and third places. So in the other quadrilateral, M and L hold the fourth and third places. So that means that HG corresponds to ML. So that means 2x minus 3 has to correspond to 8. They must be equal. So let's write that down. 2x minus 3 must equal 8. And now we have an equation to solve. We add 3 to each side. So we have 2x equals 11. We divide each side by 2. And we end up with x is equal to 5.5. Moving on, a couple of new theorems. Theorem 4.4. Reflexive property. Every triangle is congruent to itself. The symmetric property. If triangle ABC is congruent to triangle DEF, then triangle DEF is congruent to triangle ABC. We're just reversing which one comes first. And then the transitive property. If triangle ABC is congruent to triangle DEF, and triangle DEF is congruent to triangle JKL, then lastly, triangle ABC must be congruent to triangle JKL. These are the same properties that we've been using right along, but now they're just applied to triangles. That's it for today. Thank you very much.